Okay, in this segment, we're going to talk about how to solve a linear equation. What is an equation? Equations is equate two mathematical expressions together. For example, x plus 3 equals 5 is an equation, because notice that this mathematical expression is equated to another one, so that makes it an equation. So the first thing I want to do an equation, let me solve an equation. Let's do that one here. X plus 3 equals 5. To solve this equation, I have to isolate the unknown. To isolate the unknown, I have to get rid of the positive 3. There's many ways, people show it different ways, but the way I do it, I subtract 3 from both sides. You do opposite operation. Since this was addition, I subtracted 3 from both sides. These two are going to cancel each other out, so I'm going to get the x equal to 2. Notice that the original piece, x plus 3 equals 5, is the equation, and 2 is called the solution to the equation. Now, how would you check to see if 2 is actually the solution to the equation? If I substitute it back into the equation, I'm supposed to get the left side equal to the right side. So let's say I ask you, is 2 a solution? Is 2 a solution? So what I do, I write x plus 3 equals 5. Substitute 2 in both sides. 2 plus 3, 5. So I get 5 equals 5. Notice that a solution is something that it works. So if you substitute it back in the equation, the left side is going to end up being equal to the right side. That's called a solution to the equation. Now, so this one, I did one more time. See, this is the original equation. To solve it, I'm going to subtract 3 from both sides. These two cancel each other out, so you get x equal to 2. Now, if this one is 8 equal to x minus 3, it doesn't matter if I have x minus 3 equal to 8 or 8 equal to x minus 3. So if you're comfortable, you can leave it like it is, or you can turn them around and write x minus 3 equal to 8 to make them look like the previous problem. But you don't have to do that if you don't want to, but that's one way to do it. So then to solve for x, I have to get rid of the negative 3. Remember, to get rid of the negative 3, I have to do opposite operation to both sides. So I'm going to add 3 to both sides. Add 3 to both sides. So I get x equal to 11. One more time. 8 equal to x minus 3 is called an equation, and x equal to 11 is called the solution to this equation. I can do a different kind of equation. Let's say you have 2x equal to 8. Notice here I said in order to isolate the variable, you do opposite operation. Because it was plus 3, I subtracted 3 from both sides. Here I have 2 times x, so opposite operation for multiplication is division. Therefore, in order to isolate the x, I have to divide both sides by 2. Divide both sides by 2. These 2 cancel with these 2, so I get x equal to 4. And if I have a fraction next to the variable, let's say you have 2/3 x equal to 8. Now to solve for x, I can either divide both sides by 2/3, but for simplicity, I can also multiply both sides by reciprocal of this number. This number, the number that comes before the variable, is called coefficient. So I can multiply both sides by reciprocal of the coefficient. So I can multiply both sides by 3 over 2. 3 over 2. Multiply both sides by 3 over 2. You can make this one a fraction since 3 over 2 is a fraction. These 3 cancel with these 3, and these 2 cancel with these 2, so I end up with x equal to. Here, to make it easier for myself, I divide these 2. 2 goes into 8 4 times. 4 times 3 is 12. So now, so x is equal to 12 is the solution to this equation. I can have a combination of the same thing. Let's do one a little bit more, a combination of the two. Let's say you have 2x minus 3 equal to 7. Notice that this is a combination of this count and this count. So to do this, to solve any linear equation is because x is to the power of 1. So anytime x is to the power of 1, that's constitutes for a linear equation. If this was a 2 there, that would be a second degree equation or quadratic equation. 3 would be a cubic equation, and so forth, right? But we're solving just basic linear equation. To solve this for x, I have to get rid of this negative. I have to isolate the variable. To isolate the variable, I have to get rid of the negative 3. Remember, to get rid of the negative 3, I have to add 3 to both sides. So I will get 2x equal to 10. Then notice that this problem becomes one of these problems, right? So to do that, to solve this for x, I'm going to divide both sides by 2. And x will be equal to 5. Now, I can have one a little bit more sophisticated than this. Let's just do it more complicated. Let's say I have x's on both sides. Let's say I have 8x minus 3 equal to 2x, 6x, plus 9. To do this problem, I want to bring all my x's to the left side and make it look like one of these problems. So to do that, you want to collect all your unknown in one side and all the constant on the right side. That's one way of doing it. So I want to collect all my x's in the left side. To do that, I need to get rid of the 2x in the right side. So to get rid of the 2x in the right side, I subtract 2x from both sides. So these 2x cancel each other out. 8x minus 2x will give me 6x minus 3 equal to 9. To solve for x, I have to get rid of the negative 3. To get rid of the notice that by doing that, I got the problem look like the previous problem. So that shows you how they are related together. You do one step, you get back to the previous problem. Now, remember how I did in previous problem? In order to solve for x, I isolated the x by getting rid of the negative 3. Here, in order to solve for x, I have to isolate the 6x. In order to isolate the 6x, I have to get rid of the negative 3. To get rid of the negative 3, I add 3 to both sides. So that will give you 6x equal to 12. To solve for x, notice the difference. It's similar to these problems, right? So divide both sides by 6. And x equal to 2. X equal to 2. Next thing, we're going to translate verbal expression to algebra.